Well, I did all of the block 2 exam 3 practice sheet and I forgot to hit record. And I did it in Discord and I don't think anyone was in there. So it's, it's fine. Okay. We'll start with problem 1. And I will do each problem, well, the front page, problems 1 through 3, I'm gonna do just using dimensional analysis so that we can get comfortable with it. And then on problems 4 and 5, I'll show you the formula method and we'll just see if that helps you any, because some people do like the formula and I'm not going to knock it because it still works. It gets a little trickier to use. So we'll just start here. And keep in mind, the whole thing with dimensional analysis is you want to know what you want to end up with. So when you read the problem, you think, what is it asking? Is it asking me for a time? Is it asking me for a measurement of volume? Is it asking me for a distance? Like literally, what is it asking me for? So just keep that in mind as you read these problems and as I read them, so you kind of know where we're going to go. So number 1 says an IV is regulated at 150 drops per minute. The drop factor is 20 drops per milliliter. How much fluid volume in milliliters will the patient receive after 40 minutes? Okay, so what is it asking you for? How much fluid volume in milliliters will the patient receive? So how many milliliters? Got it? Perfect. Okay. So we have a drop factor of 150 drops per minute. 150 drops per minute per 1 minute. Okay. Then we know we have a drop factor of 20 drops per milliliter. So we want to cross out drops. So the drop is going to have to go on the bottom. It's 20 drops per 1 milliliter. And we know that we want the milliliters to be on the top because that's what we want to end up with. We're looking for milliliters. Our answer is going to be a number and some milliliters. Okay, so we know whatever we want the answer to be in, whatever units we want it to be in, it needs to be on the top of the fraction and it needs to stay up there. So we have that. And then we know that they're going to be getting this for 40 minutes. So 40 minutes. So now we can go through and cross out our units. Is there a drop on the top and a drop on the bottom? Yes. Milliliter on the top and a milliliter on the bottom? Nope. Minute on the top and a minute on the bottom? Yes. So we can go on to multiply. And it's going to be 150 times 1 ml times 40. Because we crossed out all those units, right? And then the bottom, we have 1 times 20 times 1. So when you multiply all this out, you get 6,000 over 20, which ends up giving you 300. Remember, because we have the milliliters. Boop. 300 mLs. So that's how many, that's the fluid volume in milliliters after 40 minutes. Okay. So we'll go on to number 2. All right. Number 2. An IV is regulated at 30 drops per minute. The drop factor is 15 drops per milliliter. How much fluid volume in milliliters will the patient receive after 4 hours and 10 minutes? Okay. So, what is it asking us for? How many milliliters? Right? How many milliliters? So this one's a little different in that they gave us the time in hours and minutes. So we know that we have our regulation, IV is being regulated at 30 drops per minute. So we need to change the hours into minutes so that we can use it. So you can do it like this. We'll just do 4 hours times 60 minutes because there's 60 minutes in an hour, right? And that gives you 130 minutes. But we also have the 10 minutes that was left over, right? Plus 10 minutes means that we have 140. Oh, shoot. Sorry. Can you tell I'm sleep deprived? It's 120 minutes. And then we have 10 minutes left. So that gives us 130 minutes total. Okay, so now we know the minutes. We'll go ahead and write out all our stuff that we would normally write out. XMLs. And we have a regulation of 30 drops per minute. And we have a drop factor of 15 drops per 1 ml. And then we have 130 minutes is how long it's being run over. Whatever. So let's cancel out our units, make sure everything matches up and cancels out. Drops cancel out, minutes cancel out, and we're left with milliliters, which is what we want. So we'll put it all together. 30 times 1 times 130. And this is all going to be in what unit? Milliliters. And it's going to be over 1 times 15 times 1. So when you work all that out, you end up with something like 3,900 over 15, which ends up being 260 milliliters. I guess I should check my answer. Oh. Fudge. $30 drops per minute. Let me double check my answer real quick. 30 times 30 over 15. $260. 500 though. I see my problem here. Wow, I'm dumb. Sometimes my brain just doesn't work. The problem is it's 240 minutes plus 10. There's 250 minutes. This is why you always check your work, right? Ends up giving you 500 milliliters. All right. Cool. Okay. Golly. Brain. This is not right. 4 times 60 is 240. minutes. So these all change to 240. Sorry, I have half a brain right now. Okay, so 4 hours times 60 minutes plus 10 gives you 250 minutes. So you end up with 30 times 1 times 250, and then you end up with 15 on the bottom. That gives you 500 milliliters. There's your unit. It transferred. So there you go. There's your answer. Good night. My brain is so tired. Sorry, guys. Okay. So we'll move on to the next one, which is similar. And hopefully my brain doesn't muck it up this time. So you have an IV regulated at 40 drops per minute. The drop factor is 15 drops per milliliter. And you're running it for 6 hours and 15 minutes. And they want to know how much fluid volume in milliliters. So let's get it crack-a-lackin'. We'll start with the time. 6 hours and 15 minutes. So, you know, 6 times 60 plus 15 will give you 375 minutes. 6 times 6 is 36. Is that right? 360 plus 15 is 375. Okay, cool. So you have your time in minutes. Now we're gonna look for XMLs. Your drop rate, or your regulation, is 40 drops per minute. Your drop factor is 15 drops per milliliter. And your time in minutes is 375. So we can go ahead and cancel out our units. Drops cancel each other out. There's 2 minutes. And all we're left is milliliters. Perfecto. So it ends up being 40 times 375 over 15. Which in turn gives you 1,000 milliliters. All right. Now we're cooking. Okay. So these are the last two. I'm gonna do them half in the formula and half in dimensional analysis. So let me check something real quick. Okay. We will do this. Let me answer this right. Okay. Let's do this, and then I'm gonna do another problem, and we'll see where the wind takes us. Okay. So number 4, it's regulated at 25 drops per minute, and the drop factor is 15 drops per milliliter. And they want to know the fluid volume after 5 hours. Okay, so this is just how we did it before. XMLs. We know that we have 25 drops per minute. And then we have 15 drops per ml. And here's a fun trick. you have 5 hours, but you really want minutes, right? So you have 5 hours over 1. And you know there are 60 minutes in an hour. So we'll go through and cancel out our units. Drops cancel each other out. Hours cancel each other out. Minutes cancel each other out. And again, surprise, surprise, we're left with milliliters. So when that all works out, you end up having 25 times 1 times 5 times 60 all over 1 times 15 times 1 times 1, which then gives you 7,500 over 15 mLs. Translate that to 500 milliliters. All right, time for the formula. So the formula for these problems is drops per milliliter, or per minute, sorry. Drops per minute is equal to amount of solution times drop factor over time. So the amount of solution is going to be in mLs. The drop factor, like we've seen before, is drops per milliliter. And the time is always in minutes. So with this problem, it's all about solving for what you're missing. Do we have something that's in drops per minute? Yes, we do. It is 25 drops per minute. Do we have an amount of a solution? Nope, that's what we're looking for. So that's going to be X. And then do we have a drop factor? Sure do. It's 15. 15 drops per milliliter. Okay. And then do we have a time? Well, we know we have 5 hours, but we want it in minutes. So 5 times 60. So when you work this out, it ends up being 25 is equal to 15x over 300. So then you can cross multiply and you end up with 15x is equal to 7,500. Then you can do some algebra and divide by 15 on both sides. X is then equal to 500 milliliters. So that's the formula method. Like I said, I'm not a huge fan of it, but some people like it, so it's good to know. All right, we'll do this problem and then we're gonna do number 10 for Janine. Okay. I guess this is number 10 on the first sheet. That one's a trick question. I think they did it wrong. Anyways, we'll continue. Okay, so 5 says an IV is regulated at 20 drops per minute. And the drop factor is 60 drops per milliliter. And they want to know, again, how much volume in milliliters are they going to get after 5 hours. So we want XMLs, right? We have 20 drops per minute. And we have 60 drops per milliliter. And then we have 5 hours. But we know that, how do I want to say this? There's 60 minutes in an hour. Dang, this Animal Crossing is slaps. Well, I forget that I have music on sometimes and then it gets really distracting for me. Okay, continue. Onward. So we'll go back to canceling out our units. Drops, cancel out. Hours, cancel out. Minutes, cancel out. And once again, we're left with milliliters. So it's 20 times 1 times 5 times 60. All over 1 times 60 times 1 times 1. You work all that out and you end up with 100 milliliters. Okay, cool. So now we'll do the other way with that formula. So our drops per minute is 20. And we don't know what the milliliters is, so that's going to be X. But we do have a drop factor of 60. And we have 5 hours, but we want it in minutes, so we're going to multiply that by 60. So what you end up with is 20 is equal to 60x over 300. Do a little cross multiplication action. End up with 20 times 300, which is equal to 60x. Then you divide both sides by 60. X gives you 100 milliliters. So that's it. Yes. So I'm going to stop recording this and then go do the rest in Discord. But essentially that's that. So if you have any questions, let me know. And if you don't, then awesome. Good job.